Hi everyone! Today's lesson is on special products of polynomials. As you can see, I have completed your do now, so I'd like you to pause this video and do that on your own and then check your answers. I just want to remind everyone that today your homework assignment will be to complete the practice at the end of the notes packet. So numbers 1 through 12, I'll put this on Schoology. I also just want to remind you guys that I am checking your homework assignments to make sure that you are putting in the work that is required, but I'm not checking your answers. So you definitely need to go back into our distance learning folder and look in the answer key folder to check your work. I want to answer any questions that you guys have, but I need you to take on that responsibility. Okay, so today's notes start with multiplying a trinomial times a binomial. Now, we talked about a couple lessons ago that a trinomial has 3 terms and a binomial has 2 terms, and we will be multiplying 3 terms by 2 terms. So I'm gonna first use a model, and then there is an example for you guys to try. Here I have 2 terms, x minus 2, in one polynomial times another polynomial that has 3 terms. So the process here is exactly the same. We just have to account now for another term. So I'm gonna start by multiplying all of these by x. So that's going to give me x times x squared is x to the third, x times positive 3x is positive 3x squared, and x times negative 5 is negative 5x. So that takes care of this first term times all 3 terms in the second polynomial. And now I do the same process using negative 2. So again, it's just repeated distribution. So negative 2 times x squared is negative 2x squared. Negative 2 times positive 3x is negative 6x. Negative 2 times negative 5 is positive 10. And now my last step is to combine like terms. So I'm going to have x cubed. X cubed. This is going to give me positive 3x squared minus 2x squared is just going to give me 1x squared. Negative 5x and negative 6x is going to give me negative 11x, and then I have positive 10. And there is our polynomial. So again, at this time, you guys can pause and try the second example, and then I will do it as well. Okay, so here we go. Just getting my calculator. This time the trinomial is written first, but that doesn't matter. You can still follow the same process, except I'm gonna go start with the first term and multiply it to the 2 terms in the second quantity or second polynomial. So this is gonna be 2x squared times 4x. 2 times 4 is 8. X squared times x is x to the third. Remember, we are adding those exponents, and this has an exponent of 1. 2x squared times negative 3 is negative 6x squared. And now I do the same process for 5x. 5x times 4x is positive 20x squared, because this has an exponent of 1. 5x times negative 3 is negative 15x. And now I do this process one more time using the negative 1. Negative 1 times 4x is negative 4x. Negative 1 times negative 3 is positive 3. And again, we just combine like terms. 8x cubed. This is going to give me positive 14x squared when I combine negative 6 and positive 20. Negative 19x on positive 3. And there is your simplified polynomial. Okay. So now I want to look at a very common misconception that occurs when students are multiplying binomials. So this problem starts as x plus 3 to the second power. I'm going to rewrite it up here so you can see what it looks like to begin with. And I might say find the product. And what a lot of students like to do with this is almost distribute that exponent. So they'll tell me that x plus 3 to the second power equals x squared plus 3 squared, which would then simplify to x squared plus 9. So let's test this. So over here, I'm just going to test this. This is going to be our common misconception. And here I'm going to plug in a value for x. So let's say x were equal to 2. Okay? Based on what we just did, we should get 2 squared plus 9, which would give us 13. Okay, so let's see that over here. If we did 2 plus 3 to the second power do we get this 13? Well, 2 plus 3 is 5. So this would give me 5 to the second power, and that would give me 25. So hopefully you guys are seeing right here that we don't get 13, and therefore this is wrong. I need to point this out now because this is such a common misconception when we have a binomial to the second power. So over here, I'll just write 13 does not equal 25. So over here, we're going to talk about how to actually expand this. So when you have x plus 3 to the second power, you have this quantity multiplied by itself 2 times. So we're going to rewrite this as x plus 3 times x plus 3. And now you can multiply the way that you learned yesterday. So x times x is x squared. And again, we're just using that repeated distribution. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. So we get x squared plus 6x plus 9. Going back to this example where I had x equals 2, if I plug that in here, 2 squared is 4. 6 times 2 is 12. If I do 4 plus 12, I get 16. If I do 16 plus 9, I get that value of 25. So again, this is wrong. And I can't stress that enough, okay? All right, so now I want you guys to pause the video. The next part is the discovery. It says, find the product of each of the following. Do you notice a pattern? So if you pause the video, I want you to multiply these two and simplify like we've been doing. So I'm gonna go ahead and do that now. 3x plus 4 times 3x plus 4. That's gonna give me 9x squared plus 12x plus 12x plus 16. And then when I combine like terms, I get 9x squared plus 24x plus 16. Here I have 5x minus 2y, 5x minus 2y, and this is going to give me 25x squared minus 10xy minus 10xy plus 4y squared. So I get 25x squared minus 20xy plus 4y squared. Okay, so what I want you to notice here, and hopefully you maybe saw a pattern, especially with these two middle terms in both of these examples. Let's call the first coefficient A, or I should say the only coefficient, well, in this one, and then let's call this guy B, okay? Notice that for this example, A was 3. Well, at the first term, I lied. We're not calling it the coefficient. We're calling it the first term. So the first term was 3x, which is our A value, and the second term was 4, which is B. Notice that at the end down here, I had 9x squared. So this 3x basically just got raised to the second power. This A value just got squared because 3 squared is 9 and x squared is x squared. In the middle, we had a 12x and a 12x that combined for 24. Well, what I noticed about this 12 is that's just A times B. But again, we had 2 of them. So this term was 2 times A times B, these 2 terms in the middle. And then at the end, I had 16. And what I know about 16 is that's B squared. So if you look at this, what really happened, I'm actually going to summarize it down here, is we got A squared. At the end, we got B squared. And in the middle, we had plus 2, because we had 2 12s, times A times B. Now, I'm wondering if that pattern applied here. So if this was my A and this was my B, does that pattern still apply? Well, if I square A, 5x squared is going to be 25x squared, which is what we got. If I multiply 5 times negative 2, I'm going to get negative 10. And if I double that, I'm going to get negative 20. And then also x and y come along because it's 5x and 2y, not just 5 and 2. So here I have negative 20xy, so that works. And then here, if I square negative 2y, I'm going to get positive 4y squared. So that works as well. So when it was subtraction, it's the same thing. I got A squared, and I got positive B squared, But in the middle, the only thing that changed for subtraction is it was minus 2ab. This stays as a plus sign because when you square a negative, you still get a positive. So this pattern works. So now instead of actually multiplying out, let's see if I can use the pattern here. I'm gonna square the first term, so that's gonna give me x squared. I'm gonna double these two combined. So x times 5 is 5x, times 2 is 10x. And then I'm gonna square the last term. So that's gonna give me positive 25. And now I don't actually have to expand. I can use this pattern to multiply. Let's do the next one. 2x squared is gonna give me 4. I said that kind of weird in my tone. The quantity of 2x squared is gonna give me 4x squared. 2x times negative 3 is negative 6x. If I double that, I get negative 12x. And then negative 3 squared is gonna give me positive 9. So here you can kind of see us multiplying using that pattern. And this pattern will always work whenever you are squaring a binomial. And that's why this is called the square of a binomial pattern. All right, so now we're gonna do another discovery. So again, I suggest you pause the video at this point, and I'd like you to find the products for each of these and then see if you notice a pattern. Take a second and see, okay, what's happening here? Do I see anything similar in both examples? All right, so I'm gonna do this out. So we're gonna get t squared minus 5t plus 5t minus 25. Now, be super careful here. You wanna make sure your plus signs and your t's look a little different. I try to curl my t so that they look different. That's gonna leave me with t squared. Well, those are gonna cancel when you combine them. And I'm gonna get minus 25. I should curl my t here as well. Okay, over here, I'm gonna get 9x squared minus 3xy plus 3xy minus y squared. That's gonna leave me with 9x squared. These are gonna cancel, and I get minus y squared. So hopefully, if you guys pause the video, you gave your, oh, my phone, hang on. Are we still recording? Okay, so hopefully if you guys pause the video, you gave yourselves a second to realize that in both examples, the middle terms completely canceled. And this is a result of multiplying the sum and the difference binomial. So it's the same binomial, except one is the sum and one is the difference. Same thing here, same binomial, except one is the sum and one is the difference. And this pattern will always be true. Now, what pattern exactly happened? If we look at the first one, again, let's go back to that a and b idea. Well, we went from t to t squared. So a got squared. And then here, b, if this is a and b as well, when we square the two b's, we're going to get 5 times negative 5. So we're going to get negative 25. So this just becomes, if I'm looking at the rule down here, a plus b, a minus b, we're going to square a. So we're just going to get a squared. And then we're going to get the negative of b squared, like we did here. Same thing here. A is 3x for both. So if I square 3x, I get 9x squared. And b is y. So I'm going to get minus y squared. So now again, I don't need to expand and use that repeated distribution. I can just use the pattern. I notice I have the same binomial. One's positive, one's negative. So I'm just going to square the first term, get x squared, and subtract the square of the second term. 3 squared is 9. So I get x squared minus 9. These patterns will always work. One thing I want to point out, this was when you have the same binomial to the second power. So 3x plus 4 means I'm multiplying that same binomial. Same thing here, same binomial. For this pattern, it has to be the positive and the negative of a binomial. The positive and a negative of a binomial. So just be careful when you're using those patterns. All right, guys, that's it for today. If you have any questions, shoot me an email or post on the discussion board. Again, your homework's going to be to complete this practice, numbers 1 through 12, and I will post the key for the next class day. Thanks. See you soon.